In this lecture, we will learn about the radix sort and how to implement it in Python. The radix sort is used to sort integers. It sorts the digits, starting from the rightmost significant digit and progressing to the left. Let's look at a conceptual example so that we understand how this algorithm works, before we move on to writing the C# code to implement it. We start out with the following collection, 3 integers, 101, 304, and 400. The rightmost significant digits are examined. For the number 101, 1 is the rightmost digit. For 304, 4 is the rightmost digit. For 400, 0 is the rightmost digit. On the first pass, this algorithm will rearrange the numbers in order of their rightmost digits from least to greatest. Since 0 is the least of the 3 numbers, 400 is bumped to the front of the collection. 1 is the next smallest, so 101 becomes the second item in the collection. 4 is the largest number, so 304 comes last in the collection. Next, the middle digits are examined, since this algorithm starts from the right and moves 1 digit to the left each time. Since all of the middle digits are 0, the elements in the collection stay in the exact same order. Now, the leftmost digits are examined. 101 is moved to the front of the list, since 1 is the least of the 3 numbers being examined. Then comes 304, since 3 is the next smallest digit. Finally, 400 is positioned at the end of the list, since 4 is the largest of the digits being examined. Now the radix sort has completed, and the list is in order. Let's look at how we could write a Python function to implement a radix sort. To start out, we will use Python's def keyword and name our function radix sort. Our function will take in one parameter named elements. Inside of this function, we will have a variable named placement, set equal to a value of 1. Then we will have a variable named max digit, set equal to max elements. After that will come a while loop that will execute while placement is less than max digit. Inside of the while loop, we will have a variable named buckets, set equal to the result of list for underscore and range 10, inside of square brackets. Then will come a for loop for I in elements. Inside of the for loop, we will set temp equal to the result of I divided by placement modulus 10, cast to an int. Then we will call append on buckets at index temp, and pass I into the append function. Outside of the for loop, we will have a variable named a set equal to 0. Then we will have a for loop that is for b in range 10. Inside of the for loop, we will have a variable named buck set equal to buckets at index b. Then we will have a for loop for I in buck. Inside of this for loop, we will set elements at index a to the value of I. Then we will increment the value of a. Outside of the for loops, we will multiply placement by 10 and assign it to the value using the times equals operator. Then we will return elements. Now that we have finished our radix sort function, it's time to test our code. We will print out the result of a call to the radix sort function with a list with the elements 401, 503, and 104 passed in. When we run the code, you will notice that the list elements were sorted thanks to our radix sort function. In the next lecture, we will learn about the heap sort and how to implement it in Python.